So hello dear student, welcome to GPAT discussion center. In today's session we will start with the inorganic chemistry, and in today's session we will discuss the first chapter of inorganic chemistry, that is limit test. So limit test, as you know, we were performing the limit test in our Pharm first semester in the inorganic chemistry. Like when I was in my Pharm, I usually go to college in the timing around 9 to 5, and I remember that every morning at 9 a.m. There is a limit. I have to do limit test. So as the limit test word come in the mind, I had strike that limit test of chloride, limit test of sulphate, iron, arsenic. So as you are familiar about the word limit test, so limit test are basically of 5 type in our GPAT NTA syllabus. One is of limit test of chloride, second is limit test of sulphate, and third is limit test of iron, fourth is limit test of lead, and fifth is limit test of arsenic and heavy metals. So we have to discuss all these 5 limit tests in detail, and hopefully the question will ask from these 5 limit tests. And as there were many questions in the previous GPAT and NIPER exam from the limit test, so we will start with the limit test. So basically limit test is semi-qualitative and semi-quantitative. Semi-qualitative and semi-quantitative means they can, by the limit test we can identify that which type of impurities is present in our given sample. Either the impurities is of chloride, either the impurities of sulphate, and either the impurities of iron, lead, whatever the impurities is present in the limit test. We can identify the quality as well as quantity of that impurities, and we can also identify the group, or we can say atom present in a given sample. So our limit test is semi-quantitative and semi-qualitative. And I hope you remember that our limit test is usually performed in a nasal cylinder. Nasal cylinder, you are able to see, that is the big version of our test tube. I hope you all had seen the test tube in your Pharm, as well as we usually prefer the practicals in our 11th and 12th class. So the big version of our test tube, we can say, is our nasal cylinder, that is having the volume of 50 ml. That is having the volume of 50 ml, and we can perform the limit test of chloride, sulphate, iron, lead, and heavy metal in the nasal cylinder. As there is special apparatus for the arsenic, that is 𝘖𝙎 apparatus is usually used to perform the limit test of the arsenic. But there is a line in the Indian pharmacopoeia that the lead test is performed in separating funnel. In separating funnel, I think you had remembered that there is a type of funnel. Funnel doesn't mean like this type of funnel. This is the normal funnel, but our separating funnel is somehow like this. This is type of separating funnel, or I hope you had seen the separating funnel. So according to our IP, the lead test, or the test of lead is performed in a separating funnel, and the test of 𝘖𝙎 apparatus, or we can say the test of arsenic, is performed in 𝘖𝙎 apparatus, whereas the test of chloride, sulphate, iron, and lead as well as heavy metal is performed in the nasal cylinder, that is having the volume of 50 ml. So first we will I am showing you that this is our nasal cylinder. I hope you are able to remind or recall this, that this is a type of nasal cylinder, and hopefully you had also remind that we are preparing 2 type of solution. One is standard solution and one is test solution. And usually we perform the limit test of chloride, sulphate, and iron. And in these tests, like in case of chloride test, we are usually comparing the turbidity. Turbidity means like one is how much amount turbid than the other. Just we can compare the test with the standard if they can match, or there is a up and down, and according to that we can identify that this limit test is our limit test pass or fail. So we will discuss one by one when our limit test will fail and when our limit test will pass the limit test. So I hope you had remember that there is a test of chloride. So limit test of chloride. In the test, we are usually prepared two solution. One is test solution and one is standard solution. The data or how we can prepare the standard solution is given in the Indian Pharmacopoeia or USP Pharmacopoeia. We usually prefer Indian Pharmacopoeia in our laboratory. So the procedure how to make the standard solution is given in the Indian Pharmacopoeia, and tested are the sample whose limit test we have to do, and we have to compare this test sample or this test solution with the standard solution. So there is a method that we have to pipette out, like we are using the pipette, like that is having the maybe you will use the pipette of 5 ml, you will use the pipette of 10 ml, but you have to pipette out, like you have to pull out 1 ml of standard sodium chloride solution into the natural cylinder. Like there is a standard solution and which we have prepared by following the procedure in the Indian Pharmacopoeia, and from this you have to just pipette out the 1 ml of solution of sodium chloride, that is NaCl, in a natural cylinder that is having the volume of 50 ml. Got it? And after that you have to add 10 ml of dilute nitric acid. 10 ml of dilute nitric acid means we have to dilute the nitric acid with water or with any other solvent that is suitable to the nitric acid. Now after that we have to dilute it with the distilled water to 50 ml. Like what we exactly do here, we are doing like we had made this standard solution by following the Indian Pharmacopoeia procedure, and from that we had taken 1 ml of NaCl and put it into the natural cylinder. This is our natural cylinder. Got it? And then we are putting 10 ml of dilute HNO3, 10 ml of dilute HNO3 into this natural cylinder, and then we are adding or we are make up the volume of it with 50 ml. Like we are adding the remaining amount, like 10 is our dilute HNO3, 1 is our NaCl, 1 ml is our NaCl, and we are make up the volume up to 50 ml. Like we have to add 39 ml of water into the standard solution. So this is our standard solution. Now there is a turn to make the test solution. So for test solution we have to dissolve the specific quantity of given sample. Like when I was in my B Pharm and my professor usually give us the solution that is usually prepared by him and or we can say lab technicians. Like just we have to test this sample that this test is pass or fail, there is impurities or not, there is a presence of chloride, sulphate, iron, whatever the test it is. So dissolve the specific quantity of a given sample in distilled water in the natural cylinder, mark as the test. Like we are taking two natural cylinder, we have to make one is S for standard, and next we have to make T for test. So after that like there is the same procedure for the remaining step. Like we are adding 10 ml of dilute HNO3, dilute nitric acid into it. We are adding 10 ml of dilute nitric acid into it and dilute it with distilled water to 50 ml. Like we have to make the volume up to 50 ml, like the remaining amount of water I have to add to make it 50 ml. So this has become our test sample. So how the reaction will proceed and how the limit test will proceed, like this reaction is based on the reaction of soluble chloride, that is we are taking NaCl from where there is a soluble chloride with this silver nitrate that is AgNO3, and in presence of dilute nitric acid. In presence of dilute nitric acid we are adding 10 ml of dilute nitric acid to form AgCl. There is a precipitate formation of AgCl which appear as solid particles या फिर opalescence in the solution. Like we can see that there is a opalescence means there is cloudy solutions. Like suppose when we add a few drop, like we take a glass of water glass of water, and we are adding few drops of we can say milk on it. So this become the water become cloudy. So the same type of appearance is seen in this type of limit test, that there is a cloudy appearance of that particular solution. So solid particles are appear to be there in the solution. So there is a precipitation of AgCl and NO3 is released. So we are making the standard solution by taking the concentration. This is very important, that the concentration of 25 ppm 25 ppm chloride is used to make the standard solution. This is very important. But it next is like, what are the role of HNO3, like why we add HNO3 in the limit test of chloride. So dilute and HNO3, as this is the acid, so this is very obvious that it make the solution acidic. So but this is not the only function of our HNO3. There are one other function of HNO3, like it make the solution pH to be acidic, like it make the solution to be acidic. That is very good. Next is its so common ion effect with uh, its so common ion effect with solution to prevent precipitation of radicals. Like it prevent, it show common ion effect, like it show like common ion effect means like HCl, like HCl is form H positive. So there is a formation of common ion effect, like the common ions like H positive from the HNO3 as well as the other ions is also making the common ions, like some are making cations, some are making anions. So prevent the precipitation of radicals like HNO3, AgNO3 and phosphate and sulphate. So there is a prevention of this type of radicals formation. And our AgNO3 is having one more interesting function, like our AgNO3, not HNO3, like AgNO3 that is responsible for the turbidity, as our chloride ion is react with the AgNO3 and it will prevent, AgNO3 from AgNO3 Ag come, and from the chlorine, that is there is a formation of AgCl, that is the precipitate form in the reaction. And that you are able to see that Ag positive and NO3 negative, that is AgNO3. Got it? And like this NO3 and HNO3, from HNO3 there is NO3 also. So there is a common ions like nitroso ions is there. So this is that's why our dilute HNO3 makings, or we can say showing common ion effect. That's why there is a prevention, or we can say this can prevent the formation of radicals like HNO3 and AgNO3. Got it? So how we can say like this is the common reaction of our limit test of chloride. So we are able to see that there is a formation of turbidity. As I told you, like AgNO3 is responsible for the turbidity. So there is a turbidity formation in the test of limit test of chloride. As like this is our standard solution, suppose this is our standard solution and this is our test solution. Like we are what we had done in the limit test of chloride, like we are doing first we are making the standard solution by following the Indian pharmacopoeia, or we can say by using the 25 ppm chloride concentration, and we are adding 1 ml of our chloride ion as well AgCl and 10 ml of HNO3, and diluting it will be water to make the volume by 50 ml. So the same is procedure is like in this, like we are pipette out the 1 ml of solution of given test solution for which we have to do the limit test. So at the end there is a formation of turbidity. So how we can say that this limit test is fail and this limit test is the pass. So like what we have to do, like we are testing the turbidity. If the turbidity is our turbidity of test sample, turbidity is greater than our, suppose this is our test sample and this is our standard solution. If turbidity of test sample is more than the standard, if turbidity of test sample is more than the standard, then limit test fail. Like if turbidity is more, turbidity of limit means limit test fail when the turbidity of test sample, like this is our standard and this is our test. If the turbidity of test sample is more, then limit test will fail. If turbidity of standard is more than the turbidity of test, then it will pass. If TT of ST of standard, and this will pass. If the turbidity is less, we can say turbidity of our test is less than the turbidity of standard, then this will pass the limit test. So how we can check the turbidity? Like just I am doing this and this is possible? No, there is a proper procedure to see that is the limit test is pass or fail. So what we have to do, we have to just take two of the test, two of the our that is the test and standard sample, and you are able to see that I am using dark background. So I hope you are able to see that this is the nasal cylinder that is having the standard concentration, standard limit test, and this is test sample. So I am using, I am using dark background. You are able to see this that this marble is of dark in color, dark background, and I am just looking horizontally. I am looking, suppose this is our limit test, this is of standard and this is of test, and I am using the background that is dark background. Are you able to see that there is a black background around just behind me? So I am using black background, or we can say dark background, and I am observing the turbidity like this, horizontal. I am just looking for the horizontal. I am just not comparing like vertical. I am not seeing like this. I am looking like this, turbidity, test, standard, test, standard. So there is a proper procedure to see the turbidity of a limit test, and for the turbidity we have to use the dark background, and we have to observe transversely, or we can say horizontally. So you are able to recall, or there is a trick like T is for turbidity, T is for transverse, and D for dark background. So TTD, TTDP means turbidity transversely, or we can say horizontally, dark background. Got it? So you have to remember that the turbidity of limit test of chloride is checking by using dark background, and we are observing it transversely. So in exam the question will like that, is the turbidity of limit test of chloride is how we can observe the turbidity of limit test in test of chloride. So you are able to see the option vertically, you are able to see the option of we can say colored background, but you have to tick that option where there is a line that is transversely, or we can say horizontally, and against dark background. Got it? So this is the limit test of chloride. Next we will discuss the limit test of sulphate. So same procedure, like we have to make two solutions, one is standard solutions and one is test solution, and in this we are using the concentration of 10 ppm to make this sulphate concentration, to make the standard solution of sulphate. So same procedure is like that, we have to take two nasal cylinder, one is marked as a standard and one is marked as a test. So what is the procedure? Like we have to pipette out 1 ml of standard sulphate solution into the nasal cylinder and mark as a standard. So 1 ml of sulphate solution is taken and put it into the nasal cylinder, and I am marking it as a standard. Now I am adding 2 ml of dilute nitric acid. I am adding 2 ml of nitric acid, 2 ml of nitric acid into the solution of sulphate. Next, I am diluting it with 45 ml of distilled water. I am diluting it with 45 of ml of distilled water. And now what I am adding? I am adding 5 ml of barium sulphate, that is BaSO4. I am adding 5 ml of BaSO4, and immediately I am stirring. Like we have to be prepare the solution by following the proper procedure that is given in the Indian Pharmacopoeia, USA Pharmacopoeia. Like we have to be stir it immediately with a glass rod and allow it to stand for at least 5 minutes. Like we have to allow this standard solution of limit test to by stirring it immediately, and we have to wait for the 5 minutes. Now we have to observe it with our test sample. So now we will prepare the test sample first. Like how we can prepare the test sample? Like we have to dissolve the specific quantity of a given sample in distilled water in natural cylinder, like specific quantity of sample that are prepared by our lab technicians or our faculty, and we have to take the specific quantity in the natural cylinder. Got it? Now after that we have to follow in the same procedure. Like I am adding 2 ml of HNO3, that is dilute. So you have to be read the questions very carefully, that what is given in the question. After that you have to add 5 ml of BaSO4, barium sulphate, and next step you have to be stir it immediately. Like before the addition, like there is a formation of we can say turbidity. So you have to make it to be uniformly distributed. BaSO4 you should be uniformly distributed throughout this natural cylinder. So you have to be stir it immediately with a glass rod and allow it to stand for 5 minutes. We have to allow it to stand for 5 minutes. We do not have to be stir it like we are taking the test tube and moving from one point to another point in our labs. No, we have to just put into the natural cylinder stand, and just we have to wait for the 5 minutes. Now after that what we have to do? We have to just observe it under black background, as we had done in case of our chloride limit test. So same is like what is the reaction of the limit test, how the reaction will proceed. So next is the limit test of limit test of sulphate is based on the reaction of soluble sulphate with barium chloride. Soluble sulphate that we are adding with barium chloride in presence of dilute HCl, or we can say we are adding dilute HNO3. The both are equal, like there is a need of acid. So there is a formation of barium sulphate which appear as a turbid. So we can use here HNO3 as well, but preferably we can use HCl. So there is a formation of turbidity. Are you able to remind that in the limit test of limit test of chloride, there is also formation of turbidity. So what is the role of HCl in the limit test of sulphate? So sulphate, as I told you, that we are using HNO3, or we can say HCl. So in case of sulphate, in case of limit test of sulphate, the HCl is having the role that it make the solution pH acidic. This is very obvious that what the HCl do, but the acid do. They can make the solution pH acidic. So the reaction of sulphate limit test is our SO4, that is react with BaCl2, that is barium chloride, and there is a turbidity of barium sulphate is formed, and there is a release of chloride ion. So next is like as I told you that HCl, and what is the role of alcohol, and what is the role of how we can compare the turbidity. So our HCl, that is help to make the solution pH acidic. This is very obvious that the HCl is usually make the solution pH acidic, and we can use K2SO4, or we can say BaSO4. Like potassium sulphate that increase the sensitivity of test for better detection by increasing the ionic concentration of the solution. Like in the limit test of chloride, we are using HNO3, that is having the function like they can produce the common ion effect, and that's why there is a prevention of the precipitate of radicals. So same is in case of limit test of sulphate, there is a increase in sensitivity of the test for better detection by increasing the ionic concentration in the solution. Like our potassium sulphate increasing the ionic concentration of the solution, that's why it will increase the sensitivity, or we can say increase the sensitivity of our test. So in the exam the question is like that: which among the following will increase the sensitivity of limit test of sulphate? Option are like HCl, alcohol, BaCl3 and K2SO4. So you have to be tick that option that K2SO4 is increasing the sensitivity of our limit test of sulphate. So coming to the next point, like what the alcohol do in these reactions. So alcohol prevent the supersaturation. Supersaturation, we will discuss the term supersaturation in the chapter of physical chemistry, in the in the chapter of solution in physical chemistry. Like supersaturation is a condition where no more solute can be added in a solvent. Like I am just telling you the basic definition of supersaturation. Like suppose we are adding a spoon of sugar in the water, in the glass of water, then the sugar will dissolve uniformly. Then we want that we can add more and more amount of sugar in that glass of water. So there is a point at which no more sugar can be added at normal temperature. We have to be stir it, or we have to use some mechanical force, we have to heat it so that one more sugar can be added. So same is like alcohol, it can prevent the super saturation. Means like there is a proper there is a no formation of super saturation. Means like there is a no restrictions in the limit test of sulphate. Like our BaCl3, BaCl2 and SO4 can form the precipitate of BaSO4, and that becomes showing the turbidity. So next is like how we can compare the turbidity of the limit test of sulphate. So same procedure is that of limit test of chloride, that turbidity is observed transversely against the background, against the dark background. As I told you in the last part of limit test, like this is our test sample, or we can say this is our test nasal cylinder and this is our standard nasal cylinder. Just we have to use the dark background. As we have the black background in opposite me and back me, you also have to be used, like this is test sample, this is standard sample, you have to be used dark background to compare the turbidity. As you are able to see that in the turbidity there is a minute difference. If you are using like the question arises like sir, why we can use why we are using only dark background? Can we can easily do it by using the bright background? No. Like in bright background, you can not compare the little difference in the turbidity. Sometime in the limit test of chloride and sulphate, there is a very minute difference in the turbidity. So for that, if you are using a white background to compare the turbidity of the limit test of chloride and sulphate, so what we'll do? The same background is your just behind of your nasal cylinder, and same background is in your nasal cylinder. Like white is in your back and white is in your. So there is equal, like the both limit test of sulphate, both this nasal cylinder like test and standard will see like these both are having the equal turbidity. Then you can say to your professors that sir, the limit test is showing no result. I think there is an error in the limit test. I think there is an error in the method of preparation of the standard as well as test sample. So you have to be used dark background, because the white or we can say turbid is our test and standard sample. So to check the minute difference in the turbidity, or we can say to get a very good result or to get a very accurate result, we can use the dark background. Got it? And in the next upcoming limit test, we will discuss that we are using bright background. We are using bright background to compare the color of that particular limit test. So thank you everyone for joining the session. We will meet soon in the next session with the next limit test, that is limit test of iron, lead and arsenic. So thank you for joining the session. Thank you everyone.